Have you ever wondered what would happen if humanity decided to detonate all 15,000 nuclear bombs at once? Quite a chilling thought, isn't it? Well, we're about to dive into that abyss, so buckle up. Let's begin by taking a look at our current global nuclear arsenal. By today's count, our blue planet is home to around 15,000 nuclear weapons. Yes, you heard that right. 15,000. These aren't your garden variety firecrackers. These are weapons that could bring about the apocalypse. The United States and Russia are the top contenders in this grim race, each boasting a staggering 7,000 nuclear weapons in their stockpile. Between these two nations, we have 14,000 weapons that could potentially obliterate life as we know it. But let's not forget the remaining 1,000 nuclear weapons. They're scattered across various other nations, adding an extra sprinkle of doom to the mix. To put this into perspective, the combined destructive power of all these weapons is beyond comprehension. We're talking about enough firepower to wipe every city off the face of the earth. Imagine that for a moment. Every city, gone. Over 3 billion people wiped out. It's a sobering thought, isn't it? But the truly terrifying part, even after such widespread destruction, we would still have around 1,500 nuclear weapons left over. That's right, we could decimate every city on Earth and still have enough firepower for a second round. The sheer power of these weapons is a testament to the dangerous path we've embarked upon. It's a path that could lead us to our own destruction if we're not careful. So, the next time you hear about the nuclear arsenal, remember what's at stake. With the sheer power of these weapons, we could wipe out every city on Earth, obliterating over 3 billion people and still have 1,500 weapons left. So, what would happen if we detonated all these weapons simultaneously? Imagine the unthinkable. 15,000 nuclear bombs, each with a terrifying destructive potential, detonating at the exact same moment. The energy released would be mind-boggling, equivalent to 3 billion tons of TNT. Just let that sink in for a moment. To put it into context, let's take a journey to our planet's lungs, the Amazon rainforest. If this simultaneous detonation were to occur here, it would create a fireball with a diameter of 50 kilometers. Picture that. A fireball so immense it would swallow up entire towns, cities, and ecosystems in one fell swoop. But the devastation wouldn't stop there. This detonation would flatten approximately 3,000 square kilometers of forest land. That's about the size of the state of Rhode Island, reduced to nothing but ashes and smoldering ruins in an instant. And the effects would not be limited to the immediate vicinity. This detonation would have global repercussions. The shock waves from the explosion would reverberate around the world, causing destruction far beyond the epicenter. The dust and debris thrown up into the atmosphere would block sunlight, causing temperatures to plummet. This is what we call a nuclear winter. The world as we know it would be changed forever. Crops would fail, wildlife would die off, and humanity would struggle to survive in this harsh new reality. It's a grim picture, isn't it? But it's important to remember that this is a hypothetical scenario. The purpose of such thought experiments is not to scare you, but to illustrate the immense power of nuclear weapons and the catastrophic consequences of their misuse. We have these weapons, but the challenge lies in ensuring they are never used. In essence, detonating all nuclear bombs at once would create a fireball 50 kilometers across and flatten 3,000 square kilometers of land. This isn't just a disaster. It's an extinction-level event, and it's one we have the power to prevent. To give you a sense of scale, let's compare this hypothetical nuclear detonation to a historical event. Ponder for a moment on the Krakatoa volcanic eruption of 1883, one of the deadliest and most destructive volcanic events in recorded history. This cataclysmic event was so immense that it could be heard as far as 3,000 miles away, a distance equivalent to a tenth of our planet's circumference. The eruption and the consequent tsunamis resulted in the demise of over 36,000 individuals and left a lasting imprint on our world's climate, causing global temperatures to drop and weather patterns to change for several years. Now, imagine the energy of this eruption. It's estimated that the Krakatoa explosion released about 200 megatons of energy. That's an astronomical figure, isn't it? Yet if we consider the energy that would be discharged in our hypothetical scenario of simultaneous nuclear detonation, the Krakatoa eruption starts to seem almost insignificant. In our scenario, if all 15,000 nuclear bombs were to be detonated at once, the resulting energy discharge would be equivalent to a mind-boggling 3 billion tons of TNT. To put that into perspective, it's about 15 times the energy released by the Krakatoa eruption. Yes, You heard it right, 15 times. That's an energy release equivalent to detonating 15 Krakatoa eruptions simultaneously. Consider the devastation caused by the Krakatoa eruption. The lives lost, the environmental impact, the alteration of global climate. Now multiply that impact by 15. The outcome is almost impossible to fathom, isn't it? Such a nuclear detonation would not just be a disaster, it would be an apocalypse, an event marking the end of life as we know it. So, the energy released in our nuclear detonation scenario is 15 times greater than the Krakatoa eruption. The scale of this comparison serves to underline not only the immense destructive power of nuclear weapons, but also the dire consequences of their potential mass detonation. Now, let's imagine an even more extreme scenario. Picture this: humanity has mined all the uranium on Earth and amassed it into one colossal nuclear pile. The scale of this pile is almost unimaginable, containing the explosive yield equivalent to 10 billion Hiroshima bombs. For context, the bomb dropped on Hiroshima during World War II exploded with a force of around 15 kilotons of TNT. Multiply that by 10 billion and you begin to grasp the sheer magnitude of this scenario. It's a scale of destruction that goes beyond our worst nightmares. If this nuclear pile were to detonate, the consequences would be catastrophic, reshaping the world as we know it. The initial explosion would be followed by extreme temperatures, hotter than the surface of the sun, not just in the immediate vicinity, but across the globe. These temperatures would incinerate everything in their path, turning forests into ash and cities into molten wastelands. But the devastation wouldn't stop there. The energy released from such a massive explosion would trigger earthquakes of unprecedented magnitude. These seismic events would rip apart the very fabric of the Earth's crust, causing widespread destruction far beyond the reach of the initial fireball. In the aftermath of this explosion, the world would descend into a nuclear winter. The massive amounts of debris and smoke thrown up into the atmosphere would block out the sun, plunging the Earth into a prolonged period of darkness and cold. This would decimate plant life, leading to a collapse of the food chain and the extinction of many species. For large animals, including humans, survival in this harsh, radioactive landscape would be next to impossible. The extreme conditions, lack of food, and high radiation levels would lead to a rapid decline in population numbers. Over time, the once thriving Earth would become a desolate wasteland, devoid of complex life. In this scenario, the detonation would lead to the extinction of large animal species, including humans. But what would be the long-term impact of such a massive nuclear detonation? This is a question that echoes in the minds of many, a terrifying thought that we hope will forever remain hypothetical. Picture the Earth in the immediate aftermath of this unfathomable event. Our once vibrant, teeming planet would be transformed into a charred, freezing, radioactive wasteland. The detonation would have released enough energy to incinerate cities, boil oceans, and ignite wildfires on a global scale. The world as we know it would be obliterated, replaced by an inhospitable, barren landscape. The immediate loss of life would be staggering, but the ongoing effects would be equally as devastating. A nuclear winter would set in, with soot and dust from the explosions blocking out the sun's rays. This would cause temperatures to plummet, leading to a frozen hellscape that few organisms could survive. The radiation would also permeate the atmosphere and the soil, poisoning the few life forms that might have endured the initial cataclysm. Yet, even in this bleak scenario, Earth would not be condemned to eternal desolation. Over millions of years, the planet would slowly start to recover. The radioactive isotopes would decay, the temperatures would gradually rise, and life in its most tenacious and resilient forms would begin to reclaim the world. However, evidence of our existence and our catastrophic end would linger. Future geological layers would be enriched with radioactive elements, a grim testament to the destructive power humanity once wielded. Remnants of our civilization, fragments of buildings, pieces of technology, might also be found embedded in the rock strata, silent witnesses to a bygone era. In conclusion, detonating all nuclear weapons at once would lead to a catastrophic extinction event for humanity, leaving behind a world that would take millions of years to recover. This chilling scenario reminds us of the immense responsibility we bear in possessing such destructive power and the importance of ensuring it is never unleashed.